Good morning. Today we can see the power stages in three-phase induction motor. It is necessary to study the power stages because we need to find the power equations and some problems, some numericals based on this. Okay, we know in the case of three-phase induction motor, stator we are giving the input supply voltage, so that we are having a stator input power. That stator input power we can transfer that into the rotor through the air gap, that is the air gap power, that is given as the rotor input, and some of the power lost in the stator itself, that is the stator losses. It includes stator iron loss and stator copper loss. And the input to the rotor, that is converted into mechanical power, the power developed in the rotor, that's the mechanical power in the rotor, and some of the power is lost in the rotor as rotor copper loss. The mechanical power developed in the rotor, we can't obtain P out as same as the mechanical power developed in the rotor because some of the power is lost during this transition as mechanical losses. The mechanical losses includes frictional loss and windage loss. These are the power stages or power conversion happening in the three-phase induction motor. This is the rotor equivalent circuit of three-phase induction motor. And the power input to the rotor, that is the rotor input, that is the power transferred from the stator to rotor across the air gap, which is called air gap power PG. Okay, that's the power input, rotor input, that is the power transferred from stator to rotor through air gap is the air gap power PG. And from the figure it is clear that the power input to the rotor, that is only I2 square into R2 by this, because here the power, this X2 does not consume any power. Since this is reactance, it does not consume any power. Only resistance consume power. So power is, we can say that the AC power is I2 square into R2 by S, which can be rewritten as I2 square into R2 by S can be rewritten as I2 square R2 plus I2 square R2 into 1 minus S by S. Okay. Now we can recall the power stage equations we have studied. The rotor input, okay, the rotor input is converted into rotor copper loss and P mechanical, that is the mechanical power developed in the rotor. Okay, so this I2 square R2 is the rotor copper loss and this I2 square R2 into 1 minus S by S is the mechanical power developed in the rotor. Now what I am doing is, I am taking here SSLCM. So SSLCM, then it will become S into I2 square R2 by S, SSLCM here. So this equation will become same as this, I2 square R2 divided by S. This is, I can write here, into 1 minus S. See, this I2 square into R2 by S. The term is here. Here also I2 square into R2 by S. What is this term? This is PG. PG is the air gap power equal to, we know, I2 square into R2 by S. So I can write here as S into, this is PG plus 1 minus S into PG. So it is clear that this rotor copper loss or rotor ohmic loss is equal to S into PG, and this mechanical power is equal to 1 minus S into PG. That is, we can express the rotor copper loss in terms of slip and air gap power, and also we can express mechanical power in terms of slip and air gap power. Okay. So more specific, I can write the rotor copper loss is equal to S into rotor input, which is the rotor input, and mechanical power P mechanical is equal to 1 minus S into PG, that 1 minus S into rotor input. These equations will be very useful while doing the numericals. Okay. Next we can see, due to this P mechanical, that is a mechanical power, an internal torque will be developed. We know the torque equation and the relation between power equation and torque equation. P equal to 2 pi Nt divided by 60. Here power developed in the rotor is P mechanical, which is equal to 2 pi N, that is a gross torque developed in the rotor is Tg, divided by 60. Or from this I can write Tg equal to P mechanical into 60 divided by 2 pi n. Let me clear this. So I have written it as Tg equal to P mechanical divided by 2 pi n by 60. And we know P mechanical power developed is equal to 1 minus S into rotor input, that is the air gap power Pg, divided by 2 pi n by 60. Or I can write thus 1 minus S into Pg. We know 2 pi n by 60, that is omega. Here it is, n is the rotor speed, so I can write rotor angular frequency omega. So Tg can be expressed as 1 minus S into Pg divided by omega r. Okay. We can do some more simplification for this equation, like we know slip S is equal to ns minus n divided by ns. Okay, that's the equation for slip. And also this S into ns equal to ns minus n, or n equal to, and we can take it like in this side, and SNS can be taken this side, right hand side. So that will be n equal to ns minus SNS, or n equal to ns into 1 minus s. If n is like this, we can write omega also. Omega equal omega r. N is the frequency. N is the speed. So omega is the angular frequency. So I can write omega r. Here I can write omega r equal to omega s into 1 minus s. So from this I can write Tg equal to 1 minus s into Pg divided by omega r. Replacing this omega r as omega s into 1 minus s. This 1 minus s got cancelled. So Tg equal to Pg divided by omega s. This is another equation. Also we know this rotor output or mechanical power developed in the rotor is converted into, from the power flow diagram it is clear that mechanical power from the rotor, mechanical power developed in the rotor is converted into rotor output and mechanical losses. So I can say that rotor P mechanical power developed in the rotor is converted into shaft mechanical power rotor output, motor out total rotor output plus, that is a shaft power, motor and output, plus mechanical losses. Or I can write P shaft that is the power output from the shaft equal to P mechanical power developed in the rotor minus mechanical losses. Okay, the output torque or shaft torque P as such can be found out by using the equation P as such equal to 2 pi n. N is the speed of the rotor. T as such 2 pi nt by 60, that equation. Here T is shaft torque divided by 60. From this T as such is equal to P as such divided by 2 pi n by 60, or this is equal to P as such divided by 2 pi n by 60 is omega, or P as such, we know omega R is equal to omega S into 1 minus. This is another equation we can write. Also we can make a common statement that if we know the stator input, if the stator input is not, then air gap power can be Pg from the power flow diagram. Pg is equal to stator input minus air gap power equal to stator input minus stator I square R loss, stator losses, that is stator I square R loss minus stator core loss. This whole equation we can utilize for solving the numericals. Okay, thank you.